Alright, so in this video I want to talk about the difference between average and instantaneous velocity. So we've done some basic calculations with velocity, and however, I think you would agree that not everybody always moves at the same constant velocity. So let's look at an example of something that doesn't move at a constant velocity for all time. Okay, so I'm going to use a graph, velocity versus time graph, and so I'll just make up some numbers. The numbers aren't really that important. And let's say a car was at a red light, it turned green, so you slowly increase your speed, your velocity up to the desired velocity, and then after that you maintain that speed for a long time. Okay, so likewise, so in other words, the velocity is not the same for all time. Okay, likewise, suppose you were driving on the freeway for 1 hour at 60 miles per hour. Okay, I think you would agree that unless you have the most perfect calm, your foot is not jittery in the least, you were probably nobody maintains 60.000 or 65.000 miles per hour, right? So you were probably going maybe for part of your journey you were going 61 miles per hour. Maybe for another part you went 59. Maybe you got to the top of a hill and then you started going down a little hill. So maybe for that, before you realized you were breaking the speed limit, maybe you were going 68 and then you slowly tapped on the brakes. Okay, so in other words, if we're cruising in the real world, we wouldn't actually have a perfect horizontal line. It would maybe be something, it would have some wobble to it like that, right? Actually, probably every graph would have some wobble to it, because I doubt nobody really moves in a perfectly straight line anytime. Okay, so because of that, it really doesn't make much sense to say that the velocity was the same for a long time for the whole trip. So what we do is we talk about the average velocity and the instantaneous velocity. Okay, average velocity and instantaneous velocity. Okay, we know that velocity means the slope, right, on a position versus time graph, and we also know that that might not always have, the slope might not always be the same. So let's do an example. Let me work through an example to show you how we handle that. So I'll move this to the side and let's make a new graph. And let's say we thought we were going at a constant velocity, but there was some jitter like we were just talking about. So maybe there was a little wobbly line like that. Okay, now you can still say, well, let's kind of get the rough idea of what the velocity is between 0 and 3 seconds. Okay, so even though it's not a straight line, we can still approximate it by a straight line, right? So we could draw a line between the beginning and end points, and then we could draw a straight line. Okay, and let's find the slope of that straight line. So v is delta x over delta t, which is 6 minus 0, 3 minus 0, 2 meters per second. Now, when you do this, when you make a rough approximation and you draw a straight line between the beginning and end points, that is an average velocity. You're smoothing out all the rough edges. Okay? Now, if you wanted, and then so that's the average for the whole 3 seconds. Okay? On the other hand, what if for some reason you said, you know what, I want to know exactly what the velocity was at t equal 1 or time t equal to 2. Okay? Then what you need to do is you need to get a microscope and you need to look at right in that region t equal 1, and you need to find you would try to approximate, you would, with the smallest little piece of the purple graph, you would try to get a little straight piece and try to find the slope of that piece that's centered around t equal to 1. And then likewise for t equal to 2, you would find, you could approximate the slope for some little piece, okay? And so that would be your approximation for the instantaneous velocity. See the difference? Those are the velocities for the instant, 1 second after the clock started, the stopwatch, and then 2 seconds after. All right, maybe the value at t equal 1, maybe it was 1.9 meters per second. I don't know. Maybe at t equal 2, it was 2.1 meters per second. Okay, so that's the difference between average and instantaneous velocity.